The significance of Stage 2 in a Fast Breeder Reactor (FBR) program, most famously articulated in India's three-stage nuclear power program, is profound. It represents the crucial transition from merely using nuclear fuel to creating a vastly expanded and sustainable fuel supply. To understand Stage 2, we must first see it in context. Stage 1 utilizes natural uranium in pressurized heavy water reactors, PHWRs. These reactors produce energy but also generate plutonium-239, Pu-239 as a byproduct. They are inefficient, using only about 1 to 2% of the natural uranium's potential energy. Stage 2 uses this previously produced plutonium to fuel fast breeder reactors, fibers. Stage 3 aims to use the fissile material from Stage 2 to unlock the energy potential of thorium, an abundant element in countries like India. Here is the significance of Stage 2, broken down into key points. 1. Massive fuel multiplication, breeding. This is the core concept and the most significant aspect. A fast breeder reactor is designed to breed more fissile material than it consumes. It uses fast-moving neutrons, unmoderated, to convert a fertile blanket of material, typically uranium-238, U-238, into plutonium-239, Pu-239. U-238 is the predominant isotope, over 99%, in natural uranium and is essentially a waste product from Stage 1 reactors. In N fiber, this waste becomes valuable fuel. Significance: this process can increase the energy potential from a given amount of natural uranium by 50 to 60 times. It effectively turns a finite resource into a quasi-renewable one for centuries. 2. Unlocking the potential of depleted uranium and nuclear waste. The world has massive stockpiles of depleted uranium, mostly U-238, left over from conventional reactor enrichment processes. This material is currently stored as waste. Fibers in Stage 2 can use this stockpile as their primary fuel source. Significance: it transforms a long-term waste management problem into a massive energy asset, drastically improving the sustainability and economics of the entire nuclear fuel cycle. 3. Paving the way for the thorium cycle, Stage 3. The plutonium produced in Stage 2 fibers is not just for fueling more fibers. It serves as the essential fissile seed or driver for the next stage. In Stage 3, this plutonium is used in reactors, like advanced heavy water reactors or molten salt breeder reactors, to irradiate thorium-232. Thorium-232 is fertile and, when bombarded with neutrons, transmutes into uranium-233, a superb fissile fuel. Significance: Stage 2 acts as the indispensable bridge to the thorium fuel cycle. Since thorium is more abundant than uranium globally, and in specific countries like India, Stage 2 is the key to unlocking this virtually limitless clean energy source. 4. Reduction of long-lived radioactive waste. While fibers produce their own waste, they can be designed to burn or transmute the most troublesome long-lived actinides, like plutonium, americium, curium, found in spent fuel from conventional reactors. By fissioning these elements, the fiber converts them into shorter-lived fission products, which require a much shorter isolation time, hundreds of years instead of hundreds of thousands of years. Significance: this offers a potential solution to one of the biggest public concerns about nuclear power, the long-term management of high-level radioactive waste. 5. Energy independence and strategic security. For countries like India with limited uranium reserves but vast thorium resources, mastering Stage 2 is a national strategic imperative. It allows them to decouple their energy future from the geopolitically sensitive uranium fuel market. Significance: it provides energy security and technological sovereignty, allowing a nation to be self-sufficient in nuclear fuel for the long term. Summary analogy: think of the three stages like this. Stage 1, PHWRs, is like mining raw ore. You get a little useful metal, energy, and a lot of leftover rock, depleted U-238 and plutonium. Stage 2, fibers, is like a magical factory that takes that leftover rock and uses it to build both new, better factories and the specialized tools needed for the next stage. It multiplies your resources. Stage 3, thorium reactors, is like using those specialized tools to mine an entirely new, even more abundant mountain of ore, thorium, that you couldn't access before. In conclusion, the significance of Stage 2 is that it is the pivotal engine of fuel creation and sustainability. It is not just another power reactor, it is a fuel factory that dramatically extends the lifetime of nuclear fuel resources, manages nuclear waste, and unlocks the door to the ultimate goal of a thorium-based energy economy. While the technology is complex and presents its own challenges, for example, safety with liquid sodium coolant, proliferation concerns, high capital cost, its potential benefits for long-term, clean energy security are immense.